Now, I know I mentioned it is something you should check for yourself, but I didn't really talk too much about the graph of tangent, where what we get is a picture something like this. It's a very unusual looking graph that still is very periodic, but also has a whole bunch of tangents. How funny that is. But accordingly, if we want to talk about an inverse function, it's a little more complicated for tangent because we can't have that nice closed interval in the same way. If you want to get everything that tangent does, you got to open up the ends because you don't want to have those asymptotes in there. It just doesn't quite work in the same way. So for this, we're going to restrict our domain instead to negative pi over 2 to pi over 2, excluding the endpoints, which will result in getting a domain, on the other side of negative infinity to infinity for the inverse tangent function as a result of that asymptotic behavior. And that's a very important property that tangent has uniquely. That is, tangent is the only one of our inverse trig functions that we'll see here that doesn't have a very fixed and small domain on which we have to define it in pieces if we want it to behave as a function. Tangent actually goes off to infinity in either direction. And we're not going to do a whole lot with that, but I will say it's an important property to know for when you get up into calculus, because it's the sort of thing that people like to sneak in. It's an interesting problem that only really happens with arctangent and also arccotangent, but we don't talk about arccotangent quite as much. But anyway, if we want to find a value for the inverse tangent function, same idea. We just build ourselves off of the defining relationship that inverse tangent being equal, oh, what a bad habit that is. You never want to put a theta in there. Inverse tangent of x being equal to some value of theta is the exact same as tangent of theta being equal to some value x, for the reason that tangent of inverse tangent of that x is just x. But once we have that defining relationship in mind, we can then get some values using known information about tangent on the interval from negative pi over 2 to pi over 2. So for example, if we want to find inverse tangent of 1, we would just have to understand that tangent is only equal to 1 when theta is pi over 4. And that's most of all that we're going to be looking at in this chapter. There's a bit more at the end with applications that we're not going to get to, at least for where we are. And the next thing we're going to do instead is move on into chapter 5. We're going to be looking at more complicated things that we can do with these trigonometric functions. That's for another time. I'll see you then.